Hello, geometry kids. I have jury duty today, Wednesday, so I'm not going to be able to go over the review for the quarterly with you. I did give this out to you the other day, so hopefully you have it. If not, there's a copy posted on Google Classroom that you can use. But I do want to go over all the answers with you. So that's why I made this video. So that way you can't say that I didn't go over it. So I'm going over it with you now. So on number 1, it's about parallel lines cut by a transversal. But if you look at where angles 1 and 2 are, they're not going to be equal. They're not alternate interior. They're not corresponding. They're actually going to add up to 180. So you take the two expressions and you set it equal to 180. Remember, all the angles in that diagram are either equal or supplementary, and these two will be supplementary. They're called same side interior angles. You don't have to know that name, but you do have to know whether they're equal or supplementary, and these ones are supplementary. So you add them up to equal 180. So you get 12x minus 24 equals 180. You add 24 to both sides. You get 12x equals 204. And then you divide by 12. 204 divided by 12 is, I think, 17. Yes. So x equals 17. Make sure you didn't have to plug in, but it asked for which value of x would make them parallel, so it's A. Okay, number 2 is about a triangle, but they only gave you 2 of the angles. You should always find the third angle before you decide what kind of triangle it is. So 170, 155, and it doesn't matter where you put them. Add them up, subtract from 180 to get the third angle, and that angle actually comes out to be 55 also. So since 2 angles are equal, it's got to be isosceles. Isosceles triangle has 2 congruent angles and 2 congruent sides. A right triangle would have a 90-degree angle. A scalene would have 3 different angles. A right triangle would have one 90-degree angle, and an obtuse triangle would have one angle greater than 90. Okay, this one is on the current unit we're doing, so it should be easy. They gave you that AB equals RS and that AC equals RT. They show you that they're right angles. The answer is HL. Hypotenuse leg. That one should be no problem. Number 4 is also about the current unit. E is the midpoint of AB and CD. Then you have 2 pairs of equal sides. You also have vertical angles from the diagram, which shows side angle side. That one should be easy also. For 4, this is another easy one. Anytime your transformation changes size, it has to be a dilation. All the other ones are rigid motions, and they give you the same size figure. But when you do a dilation, your figure gets bigger or smaller. Okay, for number 6, I did put a graph here because it's easier to do with a graph. Start with -4, 6 would be here. Then it says to reflect it in the y-axis. Remember, these you always do the one on the right first. So reflection in the y-axis is going to bring it over to 4, 6. Because when you do reflection in the y, you negate the x. But now we have to go over the line x equals 2. Well, x equals 2 is a vertical line. That hits the x-axis at 2. So when you go over that line, you get to here, 0, 6. Choice D. That one was kind of hard. 7 is which transformation? Even though the letters look like they're swapped on the right side, it's not a reflection, because if it was a reflection, B and, like, if it was a reflection, then B, the other B would be here, but it's not. So it's not a reflection, it must be a rotation. Because if you rotate A, B, C, D to the right, it would end up on this figure. So this is a rotation. Dilation would have to change size. A translation would just move. But since the letters switched, it had to be a reflection or a rotation, but it can't be a reflection because then the letters would be in a different spot. For 8, make sure you do the dilation first. Start on the right-hand side. To do a dilation, you multiply by the 3. That would give me -6, 9. Then we do a reflection in the y-axis, which is negating only the x. 6, 9 is the answer. Choice D. Another transformation of two things. Start on the right. You got to start with the dilation. So you take 3, 5, dilate it by 2. That's going to give you 6, 10. Then you reflect in the x-axis, which would negate only the y. So you end up with 6, negative 10, which is choice B. Make sure you start on the right with these. All right, for number 10, the only one that's going to give you a non-congruent is a dilation. Any dilation will give you a figure that's not congruent to the original because it'll be smaller or bigger. 11, they want the constant of dilation, so take the image and put it over the pre-image to get the constant of dilation. So the image is that one. Take either the x or the y. It doesn't matter. The 0.63 goes on to 2, 1. Then it went down by 1/3 actually. So the answer is A. But you can just take any coordinate of the image. I use the 2 and the 6. But you can even use the 1 and the 3. You'll get the same answer. So the same thing with 12. You take the image and put it over the pre-image. They told you this is the image. So put the 6 over the 4. Image over pre-image to get the constant. 6/4 is 3/2, so it's C. For 13, you gotta know the quadrants. They go 1, 2, 3, 4. If you reflect over y equals x, switch the coordinates. Whereas 2, negative 3, it's in quadrant 4. Gotta remember those rules for transformations. Okay, rotation about the origin of 90. The rule is xy becomes negative yx. So when you switch them and only negate the one in front, you get 4, 8. For 15, if you draw the two triangles, you can see where the corresponding sides are, or you can just look at the names of the triangles. But I'll show you with a drawing. So if we have JKL, and then I label this one the same way. The statement that would be true is JL and MO because they're corresponding sides. You can also tell from J to L is there, MO is there. They're in the same spot in the name, so they have to be corresponding sides. Okay, for this one, I didn't even draw it. I just figured out BC. Since it's the second two letters, BC would be congruent to KL, would also be congruent to ST. So the answer is ST. If you draw them, you can see it also, so I'll show you that too. So if you draw 3 triangles, and you label them the same way, ABC, JKL, RST, then you'll see that ST would be in the same spot as BC. All right, for 17, they tell you that AB is equal to DE, so mark them equal, and they give you equal angles, A and D, B and E. As you can see, it's marked ASA. 18, this one's kind of hard, but when they tell you that QT is perpendicular to PQR, look at where those meet, QT, PQR. It tells you that you have right angles here and here. But also it says that QW is perpendicular to QS, which means there's another right angle here. So that's kind of confusing, but they want TQW. So we know this is a right angle right here, which means if that's 25, do 90 minus 25 and you would get 65. But we also know that this is a right angle. So if that part's 65, then this part has to also be 25, and that's what they wanted. That one was kind of tricky. The one on the test will be easier. Okay, number 19. Set these equal to 180 because they're on a straight line. 5x plus 10 equals 180. Subtract 10, you get 5x equals 170, and then divide by 5. That gives you x, but that's not the answer. That gives you x, which is 34 degrees. 170 divided by 5. And then you have to plug in, though, because they want ABD. ABD is that big obtuse angle. So you're going to do 3 times 34 plus 10, which is 102 plus 10. So the answer is 112. Choice B. And then for 20, they told you that E is the midpoint of AB, which makes those equal. And A equals B, they showed you. And then the other thing we know, even though it didn't tell us, is the vertical angles. So it ends up being angle side angle. So please study for the quarterly. You can study this packet. You can study all your notebook. Okay, it's on all the units that we've done so far this year. So you can study your notes. Make sure you know the rules of transformations. And your quarterly's Thursday. Bye.